Hello students, let's continue with MCQs on displacement, velocity and acceleration in SHM. So let's see our next MCQ. The displacement of a linear simple harmonic oscillator is given by y is equal to sine pi by 2 in the brackets d by 2 plus half centimeter. The maximum acceleration of the oscillator in centimeter per second square is, and 4 options are given to us. So let's start with the solution, students. As you can see, I want to find maximum acceleration A max. So the formula for A max is A omega square. So I need to find A, I need to find omega. Now how will I find it? So you can very clearly see I have some equation of displacement given to us. We have to just compare it with the standard equation of displacement and we'll get the value of A and omega. So to begin with, let's write the given equation of displacement, that is y sine pi by 2 d by 2 plus half. Students, this is not in the standard form as pi by 2 is outside the bracket. So let's multiply pi by 2 with both the terms. Therefore y is equal to sine pi by 4 plus pi by 4 centimeter. Student, don't be worried about y. Instead of x it is y here, as the particle may be vibrating along y-axis, hence displacement is written in terms of y. So standard equation is y is equal to a sine omega t plus alpha. Let's compare the two equations. So we will get, yes, we can very clearly see instead of omega the given equation is pi by 4. So omega is pi by 4. Also we can see instead of amplitude there nothing is written, that means amplitude is 1. So A is equal to 1 centimeter. Now let's use the formula of A max, which is A omega square. Let's substitute the value of amplitude, which is nothing but 1, and omega is pi by 4, so pi by 4 square. Pi by 4 square is nothing but, students, yes, it is pi square upon 16. Which of the option matches it? Yes, that is nothing but option D. And the right answer is pi square by 16, which is option D. Let's move on to the next question, students. The maximum speed of a particle performing linear SHM is 20 meters per second and maximum acceleration is 80 meter per second square. The time period of SHM is, that means I have to calculate T. Students, T is 2 pi by omega. That means my initial target is to find omega. Let's see how do we get it. As you can see, maximum speed is 20. So V max is equal to 20. I know V max is A omega. So A omega is 20. Let it be equation number 1. Also, A max is 80 given to us. A max is A omega square, that is 80, equation 2. Let's divide equation 2 by equation 1. Therefore, it becomes A omega square upon A omega is 80 upon 20. I can cancel A, I can cancel 1 omega. 1 omega remains and 20 4s are 8. So omega becomes 4. As I told, time period is 2 pi by omega. Let's substitute the value of omega, which is 4. So this becomes 2 pi upon 4, which becomes pi by 2. Pi is 3.14 and therefore 3.14 upon 1.57 seconds. So that is nothing but our option C. Students, let us see an alternative method if V max and A max is given to us. So I know V max is A omega, equation 1. Also A max is A omega square, equation 2. Let's divide equation 1 and 2. So I get V max upon A max will be A omega upon A omega square. I can cancel amplitude and 1 omega. Now students, T is 2 pi by omega, which can be written as 2 pi into 1 by omega. As you can see, 1 upon omega is already written as V max upon A max. So I get a very shortcut formula for finding time period, which is T is 2 pi V max upon A max. Next, also students, one more interesting fact. If I square V max and if I divide by A max, let's see what do we get here. So that becomes A omega the whole square upon A omega square, which becomes A square omega square upon A omega square. I can cancel the terms and I get Therefore, A is equal to V max square upon A max. So remember students, I have got two shortcut formulas, but they can be used only when the value of V max and A max is given to us. Let's apply it. So the same numerical now can be solved in a very fast way. So let's substitute the value of V max, which is 20, A max is 80, 24s are 80, 2 pi by 4, further it becomes pi by 2, 3.14 upon 1.57 seconds. That is nothing but option C. In the same numerical, suppose if I have to find amplitude. Now students, I have replaced period by amplitude. So let's use our shortcut formula. We'll substitute the value of V max, that is 20 square upon 80, that is 20 upon 80, 20 4s are 80, 4 5s are 20, therefore 5 centimeter, option C. That